So this time we're going to have a look at the challenge number 24. This one is about a time series challenge. So it's quite interesting to see something different. We're going to start using predictive tools again. So the idea is we want to forecast how many cells you have. What we do for the data sets, if we look at browser, we have only a single item, so we don't need to worry about group by. That's on data field, and there's some corresponding some weak numbers. We potentially could to do the data field, but time series actually just treat whatever the input data, at least the backend, the R, to treat whatever the incoming series as it is, then just run as it is, run the order. It does not consider what's the data field. It's actually just a sorting on the field. That's why it's always important to handle the missing values. The last one is a numerical column, so we have some units to forecast. Okay. We're looking to, so we want to forecast for 6 period. The confidence interval, those are the standard output in the time series tool. Let's look the values. From some of the data, however, is probably null value, so we're going to study handle the null values. For the null value, we need a monthly average. So we have a week number respect to the months. So we need to pass the data out and assign the correct week number. Okay, so yearly months. That's why for January, we have 4 months within the January. Then we want to be able to assign the moving average for the months, I think. Monthly average, yes. So for this one, we have one value that's in April. We're going to replace the null value with the average of the three values. Okay. At least the values so far, it seems to be, let's look at the units column. Yeah, for the units column, it's kept as integers. That's good. That indicates there's no null value as a text. Otherwise, the whole column will be converted as a text. So we don't actually worry too much about that. That's fine. Okay, we have some kind of missing value for the whole month. What did that do? For the number, please send the monthly average. If the monthly average also not send annual average. Okay. So let's try to handle those guys first. First month's average. We're going to drag in a summarize. Let's just do. We can do a group item. So we have as fiscal months, group by the months. Then we're looking for the average of units. Now, this time average number, we have the option to ignore zeros. No, actually, I think we can just do it without worry about the zero because the null value is just average. We can just quickly check. So, for example, for the April value, so that should be 600. That give you 7. That give you 11, 8, 7. So it's 200, 688. You need a 688 divided by 3. That's 229-ish. 229. 229 for 2012 April should be 229. 2012 April. It's not sorted. Sort 2012 for 229. Yeah, so it's 229. Because of null value, so when it's grouped by, I will ignore the null value. Then do the sum of 3 rows divided by 3. Same idea, we've got to be able to replace the missing and month value. So we're going to group by fiscal year, then the units to do average at the yearly level. There's a different ways you can handle your missing value in F1 time series tool palette. There's actually a TS filler tool available on top, or you can use, sometimes people use the multi-row formula to do those things. Nevertheless, for us, because we don't need to worry about it, we can, yeah, probably just ignore that for the moment. So let's do some join field first. So we want to join the first thing to handle the monthly value. Input data. Because we join on the fiscal months. Fiscal months, we don't care. Average units. So let's call this monthly. Monthly field. The group I should be able to handle, so we shouldn't expect anything that's misjoined. So right, nothing, left, nothing, everything is inner join. 104 rows incoming, so that's good. Then we'll repeat for the yearly join. Now the yearly join should have 2 rows, that's only 2 years we have. It's a massive number, not the best estimation, but oh well. Fiscal year, that's a yearly fill. What did I copy from? Monthly fill, yearly fill. Okay. We should expect everything to be joined. 104, that's good. Nothing missing. Nothing missing, nothing missing. So we can handle the null value first. So for us, the units, you have 2 potential if, so you need some 2 if statement twice. So as null units, and let me use capitals. As now for the monthly fill, then I need to fill with yearly fill. Else if here ALS, else if is now for the units only. Then we fill with monthly value. Else we keep the units as is. And if, so that should be able to handle all the missing values. So we can see this should be filled by 229. Because units is an integer, so it's rounded, depends on what the value is. If we go down for 23, filled with 197, yes. Let's go to the monthly missing. So this month, for 2013 May, it's filled by the yearly value. Okay, that's doing what we wanted. As I mentioned, the order matters. So because of the join, change the order. So we need to cast housing again. Okay. At least the format is good because 0102 it keeps things ordered. Just quickly check. Oh, you can use fiscal week to do that as well. August, November, January, yeah. So we don't ask it to test the performance of it. So it's always a good habit to include TS plot just to visualize data. Yeah. That's just the best way to do things. So in the setup, the data we have weekly results. So we're looking for the units. What's the interval? It's a weekly interval. We don't need it really. Can we tell them? This just set up what the later column, the year month column. Sometimes you don't need it, sometimes you may need it. Plot option, just select the first one. It give you everything else. Go with it. Run the workflow. We only have 100 rows, so it shouldn't be too bad. It shouldn't take too long to run. Ideally, you want the time series itself is a separate knowledge you need to subject to learn. Depends on the graph output. You can decide which is better model to use. For us, we have ARIMA and ETS. It does depends on the situation of data to choose. The top one is the R report. Just a single chart, not very informative, but at least we can see there's some probably cyclic behavior, some spikes. The lower anchor, we have I, which is more interactive. I try to do decomposition plot. So on top, that's exactly what I output. The second one, it converted into the yearly level. Now, because we use weekly, so you can see the x-axis is 1 to 52, so it's counting weeks. As long as you have repeating patterns, that's good. That probably indicates your time series can do a very good job to forecast those things. If we're zooming a bit, maybe here. So yeah, you have a ACF autocorrelation and PACF partial autocorrelation. Depends on data, depends on interpretation. You depend on data, you get different interpretations, and look at the lens. You can tell you, okay, what is the suitable metric to try for the model later. For us, it's out of scope for this particular video, so we'll probably just ignore that for the moment. We'll just keep default in the system. What are the continue? Generally, as long as your graph is not really going up or going down, I'll probably suggest ARIMA is your better choice. More robust, I would say. ARIMA, we the month units again. Covariance, so we don't worry about covariance for the moment. It's a weekly data. Everything else we don't even touch. Once you have a deep, much better knowledge, you can use customized model. You can run different combinations. We can ignore that. Everything else usually I keep default. Never encountered much of the US UK. That's probably just to do with how you treat start the week start Sunday or start with Monday. Default we don't change time 6 period because later we're gonna get 6 period. Control Shift B. Let's just look at the results first. As I before, time series usually takes some time to roll. It's predictive. Honduras, I probably expect 20 to 30 seconds, but if you have a much larger data set, even say thousands of data points, it does take some time to handle. I'm going to probably post a video, then come back once. Okay, it's finished running. So yeah, in the bottom, it's only 20 seconds, so it isn't too bad. You have three output anchor. Like most predictors, O is always the object, the one you use to continue to feed it into different tools. The R is your standard report, so it's the R2 report. Those are the metrics you would get if you do. Usually looking some kind of AIC or kind of RMSE values to decide if you want to, what's the better model, etc. The last one is I, the interactive one, so you get a bit visual on it. It may look very good, but actually just because it's pick a very basic model. We only have one for the first info. If you have everything zero, that does absolutely nothing. It's just flat. The one basically is trying to do just one lag. What the curve intended to do is say, okay, you give me data, I make my next forecast purely depends on one data point backwards. That's why you almost can see the entire graph is almost effectively just shifted. We don't worry too much about how this thing is. Even though you may see, oh, this looks very good, but if you actually extend the graph, because you're looking one back, it's in a down slope, it probably will keep on going down slope. So it's not necessarily the best estimation in this case. Also, lines below, ACF, PACF, those usually anything that's above the line gives some kind of indication. Okay, your metric, the parameter you use is not necessarily great. You probably want to make some justification on it. But for us, we don't worry about it. The model is built, so the idea is to forecast for next 6 period, I think. Yeah, so what forecast 6 weeks. To forecast, we have a T is forecast two. Usual order is you want to just plot, look at the data, choose your model, have some parameter, compare data. Once you decided, okay, you want to handle your forecast. We drop your forecasting. Now, the forecast data is purely depends on the object from the previous one. So you don't actually, unlike other predictive tools, you don't feed in separate data. So you do not do like a training test split. You can't. You can do it's like in downstairs you can do training test split, but it's almost like a moving window rather than say you roundly chop pieces. You cannot. The order matters. Forecast default is fine. Everything else keep it default. And shift query. Once again, I'm gonna pause the video because even the first model will take 20 seconds. We'll come back once done. So we got our final results. The overall workflow in the bottom. Let's take about. Oop, I don't want the open those. Same amount of time, 22 seconds. It's probably just because we're wrong. I cached the results quick. Object, that's the final output you're looking for. So 3.1, you're looking for 300, 334, 293. So you get 334, 293, etc. for the values. So the rest values, say you're looking for 261, 238, 261, 238. Yeah, that's pretty much value. What's the change for other decimals? Why the confidence interval will be different? Okay. We 95, 80%, 95. Curious. In between is standard output. The last one is the interactive chat. Quick note, you can actually zoom in for the tools for the interactiveness. That's probably the only benefit against your static output. And that is our challenge for number 24. So the transformation of data is not very complicated. Mostly it's about being familiar with how to use the time series tools.